Hi everybody, today we're going to look at properties of logarithms, and specifically we're going to do some basic properties and condensing of functions. If you're looking for expansion, then that's another video that you'll want to check out, but in this video I'm just doing basics and condensing. So let's start with what is basics. Let's look at some general things that happen with logarithms, like the log base b of 1 is always 0. When I think about what power of b would give me the number 1, it's always going to be 0. The log base b of b is always going to be 1. The log is really asking what exponent did I raise the base to, and if I just raise the base to power 1, then you can see that 1 coming around kind of circular there. Log base b of b to the x is just x. Remember, the question is, what power of b do I have? So b to the x is power x. And then maybe the one people struggle with more is kind of when I flip that over and it's b to the log base b of x is x. What I want you to think is when the bases match, meaning the base of the log and the base of the exponential, when they match, they kind of go away. Think of them as inverse functions. So I'm going to show you the same properties, but with e and ln, because I think that really helps. So changing that over, I have the natural log of 1 is 0. I have the natural log of e is 1. The natural log of e to the x is x, and e to the ln of x is x. I do feel like I use these four properties all the time. So these are really worth knowing, probably the bottom two more than the top two, but you do want to think that logs and exponentials are inverses of each other. That'll help us as we're trying to evaluate. So we're going to solve, evaluate, whatever you want to call it here, some basic problems just so we get a feel for what's going on. So we'll start here with the log base 7 of 7 to the 5th. The log is base 7, the exponent is also base 7, so we just bring down the 5. Next one says log base 12 of 12 to the 9th. Since it's matching, I just have 9. Natural log of e to the 6th. The base of the natural log means it's base e. I have e to the 6th, so this question is what power of e is e to the 6th? It's 6. And then I have the log base 4 of 1. Doesn't matter what the base is when I have the log of 1, that is always going to be 0. Let's try that opposite view. I have 8 to the log base 8 of 11. That is 11. 3 to the log base 3 of 20 is 20. E to the ln of 7 is 7. And then e to the ln of 1 is 1. Notice no calculators needed here. You're just looking to make sure the base of the log and the base of the exponential are the same, and then you're just kind of bringing that number out. So let's go to the product rule. The product rule can be viewed two ways. So if we're expanding, the log base b of m times n is the log base b of m plus the log base b of n. But if we're trying to condense, then we're going to take that addition and we're going to turn it into multiplication. So I have the log base b of m plus the log base b of n is the log base b of n times n. It feels like two rules, but it's only one. It's just kind of me flipping it around the equal sign to show it to you in two ways. So let's condense these. I have the log base 4 of x plus the log base 4 of x plus 3. I'm writing them as a single log base 4. I have x times x plus 3. It is not necessary to multiply the x through. You can leave it just like this. That's absolutely fine. The next one says natural log of 2x plus natural log of x plus 1. I'm going to write it as a single log of natural log. I have 2x times x plus 1. This time I put them both in parentheses. That part doesn't really matter. Next, we have the quotient rule. So again, if I'm starting with expanding, I would do the log base b of m over n is the log base b of m minus the log base b of n. But I would like to condense. So if I have the log base b of m minus log base b of n, I'm going to change that into the log base b of m over n. Looks like this. I have the log base 7 of x minus the log base 7 of x plus 9. We're going to write a single log. The base will be 7, x goes on top, x plus 9 goes on the bottom. We're done. If you want to use parentheses, you can. Next one says log base 2 of 2x plus 3 minus log base 2 of 4x minus 5. This is one log base 2, 2x plus 3 on top, 4x minus 5 on the bottom. We are not plugging in a number, we're not solving anything, we're just rewriting. Our last rule is the power rule. So if we're expanding, it's log base b of m to the p. The p comes in front. I have p log base b of m. If I'm condensing, and it won't feel like condensing, but I'll talk about it more so you can understand. If I have p to the log base b of m, that's log base b of m to the p. A lot of times what you'll see in directions is they'll say, write this as a single log with a coefficient of 1. So what we're doing is we're moving this p up to an exponent so I can have a 1 as my coefficient. Again, let's look. I have 4 log base 5 of x. I'm going to keep the log base 5 of x, and that 4 is going up as the exponent. Same thing here with -2, natural log of x plus 6. I write natural log x plus 6 to the -2, which if you wanted to, you could write this as natural log of 1 over x plus 6, and then you could square it. So I used that negative to turn it into a fraction, and then I left the power 2. Actually, lots of different ways you could write that one. You could also say natural log of 1 over x plus 6 squared if you like that better. So we're going to write this as a single log, evaluate if possible. We'll talk about what that means. So log 4 plus log 25, they're both log base 10, so we write log. I have 4 times 25. I can multiply that together. 4 times 25 is 100. Evaluate, if possible, means, well, if I have this number, like log of 100, this is just 2. Remember, we're thinking log, common log, is base 10. 100 is 10 squared. What power of 10 is 10 squared? It's 2. The same thing, I have log base 4 of 32 minus log base 4 of 2. So I put that together, log base 4, I have 32 over 2. This is the log base 4 of 16, but 16 is 4 squared, so that answer is also a 2. This one has variables in it, so it's not going to evaluate the same way. I have the log of x plus 2 minus the log of y. I'm going to write this as a single log. X plus 2 goes on top, the y goes on bottom. Let's try it again. 3 natural log of x plus 2 natural log of y. This is I have the natural log of x cubed plus the natural log of y squared. Addition becomes multiplication, so I have x cubed y squared in parentheses if you like that. Now I have 6 log of x plus 4 plus 9 log of x minus 3. We're going to make that the log of x plus 4 to the power 6 plus the log of x minus 3 power 9. So I move the 6 up to a power, I move the 9 up to a power. Now we have to deal with this plus sign. So I have the log of x plus 4 to the 6 times x minus 3 to the 9th. A little bit bigger, we're writing as a single log, coefficient of 1. So notice this half is in front of the log x plus the log of x plus 4. What I'm going to do is kind of look at it as distributing. I have half log of x plus a half log of x plus 4, just to think about that power. Now the 1/2 has a power, so let's write it, log x to the 1/2. And log of x plus 4 to the 1/2 means that the 1/2 is a square root. So I have the log of the square root of x plus the log of the square root of x plus 4. So I really expanded it just to give you like that look at what this 1/2 does. Addition says multiply them together. So I have the log. I have the square root of x times the square root of x plus 4, which you can put together as the log of the square root of x times x plus 4. So that's it of this video. I'm trying to break it up into a lot of little pieces for logs because I do think they take a lot of time and I don't want to overwhelm you. So I'll put another one up soon to do change of base. I think that's the next natural thing to do after we know these properties. Good luck.